good to go. Okay, so welcome everyone. So thank you for joining us today at our Tech Talk today. We have AJ here with us from TechSmith, and and he's an engineer at TechSmith working on. You know what, AJ? How about you tell us exactly what you are gonna be talking to us about? Yeah, I think
You
that would be better. Yeah.
you bet. Hi everybody. Well, thanks everybody who's able to make it here. Hope you enjoy this presentation. My name is AJ Oriens. I work at TechSmith Corporation, which for those of you know Jolly Road, it's right there in Okemos at the corner of Jolly meets Okemos Road. If you're familiar with that 7-Eleven, it's kind of kitty corner in those buildings there. And I'm here to talk to you about building software capital, how to write the highest quality code and why. I'm going to begin if all is good.
I think you're good.
All right, thank you. The original presentation that I sort of based this off of was done by somebody else. That guy is this guy right here from Bloomberg who presented at CPPCon. I thought he had a lot of great points, and so I more or less am showing his presentation, some adaptations here or there, but it's mainly all his. So if you're watching this after the fact, my presentation, there might be a few new things that are most important, but if you can, do go ahead and check his out, just because can't beat the original. So to begin, one day you'll find yourself with a group of other people working on something for your job. And there'll be a lot of people in that room. You'll then realize, wait a minute, I'm one of these people right here who's going to be one of the programmers on this project. And you'll look left, look right, depending on where exactly you're sitting. And you'll see that might just be it with the number of programmers on the team on this project you're going to work on. All these other people might be a couple of managers or supervisors of some sort, might be some quality assurance type people, some tech support people, and so forth as it gets all the way around. And you might be thinking to yourself, hey, there's surprisingly not that many people actually on this team that's going to be making this software product. Wouldn't it be maybe faster to get this done, faster to market, if not just me and a couple other people, or however big the size of your team is, but rather if a good portion of people were the programmers? And that's not an original idea. Many people have had this idea before. And the idea is thinking that, hey, if one person takes, say, a year to do some sort of an assignment, and two people, maybe it takes a little longer than 6 months, maybe 7, but more or less cuts it in half. And if 3 brings it down to 4 people, 5, 6, 7, and you keep going on, it actually gets done faster and faster. Of course, you're reasonable, understand a lot of diminishing returns, that it won't ever actually equal 0. It'll still be something, but more or less you might be presuming you could have such a type of graph. The more people means the less total amount of time, and thus faster to market. But to probably no surprise to anybody here, that's just not how the world works. There's this book, a lot of you, if you haven't read it already, will have to for one of your CSE courses, call it the Mythical Man Month, published 1975, that pretty much shows that this various approach is actually not at all correct. The thing is, if you do have all these people right here being the programmers, you're all working on one single code base, that what has to happen is you got to make sure your changes don't break anybody else's changes. You got to communicate. This person often needs to make sure this person's change isn't doing the same thing as him, just so forth and so forth. There starts to become lines everywhere of communication. And these lines actually will start to add up and take a lot of time. What that book is pretty much saying is, unlike that earlier graph, which it dropped down the number of months, is as more and more people are at it, it actually starts to cause an uptick in the number of months, that it takes longer and longer the number of months. And then at some point here there's such a big turnover of employees that there really is no way to really measure it. That, I can't imagine, but by the time you get somebody trained on something, that them trying to just coordinate everything, somebody probably leaves. So who knows what exactly could happen at this point. Now, this isn't to scale or anything. I don't want you to think 3 people is the optimal amount. Of course, it'll depend on what exact project you're doing. That maybe this lowest point here for a particular project is 10 people. It's not too important how much it scales. And by all means, I don't know what exact projects you might be working on. Maybe the finances of the company might be over here and be a little less optimal in terms of months to market, or it might want to have a little bit of redundancy such that somebody can take some sick time off or some vacation time, and then when they're off, it more or less works out okay for them, whatever that may be. But the idea is still, if your goal is to improve the time to market, what do? One thing you can do is try to optimize your team size, not go with hundreds of developers or employees that will ultimately make it take longer, that actually won't help you. You could try to hire the absolute top best developers, the developers with decades of experience or have proven their worth. That, of course, is a difficult thing at times, that if everybody wants to hire the best developers, how are you in your business able to hire the top developers? But what else? What else could we try to do to improve the time to market? And if you want, in the chat, go ahead, and if you have an idea or two, post it. We can, of course, talk about it. And of course, holler if you have any questions as I go with this, along with this presentation. One big idea is, what about reuse? So what that means is, say there's a component. A component could be anything. It could be a file, a project, a set of files, whatever you want it necessarily to be. And that, wouldn't it be nice if that thing, whatever that is, if it works really nice, that you could come along and just add to it, and it just fits ever so nicely on top, is able to extend it even further to do new things, and thus you're able to achieve something higher because it's on top of it, it's therefore higher, and meet the needs of more people and so forth, and it just works great. And then maybe your new thing depends on a couple of things, and that's okay. Maybe there's a couple and your thing still fits pretty nicely on top, that just works well, and so forth. Maybe you'll just keep building and building, and then that would be great if you could reuse code. That being said, what you might see happen is there'll be a component, and for whatever reason, maybe it just doesn't fit right with another component that comes later, or it could be that that new component just has some glitches to it, has various bugs, if you will, might be poorly written in various ways, such as it's hard to work with it, it's not thread safe, hundreds upon hundreds of reasons might happen. But even if it has some problems, that doesn't mean you still can't try at least to reuse it. You might start working on another part later, and then somehow it's just barely attached, or it's just attached via a couple of spots, but it does work. And then you keep trying to make more and more sort of monstrosities of some sort, that when you actually look at the architecture, it's something you're not really proud of. And this whole concept, this whole process of this happening isn't surprising how it goes about. When this first thing happens, you, the developer, programmer, whatever you want to call yourself exactly, go, hey, it works, and it does work. You might have a deadline, you might have 100 excuses, but it does work. And it's, yeah, there's a few problems with it, but you don't know if it's going to be reused later. You don't know the future. You don't have a crystal ball. But if and when it does start to become used later, you end up finding yourself in the next spot. And then once you realize that's happening, you go, well, we really should fix this someday. I can't fix it now because I got something else I got to work on. And this only took so much amount of time. I can't take too long working on the next part. I already have to probably recompile these. Who knows what exactly. And then by the time you're here, you actually go, look, we really do need to rewrite this thing. This thing's getting pretty bad now. And the hard part is, even if you're able to convince people and have that communication with management or your fellow coworkers to rewrite this thing, it actually does not go well rewriting it. Is that in terms of trying to rewrite any one of these blocks in here, it ends up sort of falling apart. That as soon as they try to fix one block, they see that that's going to break some other blocks, and it just keeps getting worse. And high turnover happens where somebody gets really frustrated with the idea of, I just want it to work, and it just doesn't. What you see happening is, over time, with technical debt, which I'll describe what that is in just a moment, it starts to rise at a faster and faster rate as time goes on. This unchecked technical debt, as I'm calling it, it not only grows, but it grows exponentially. It gets harder and harder. And it increases the time it takes to build new features. And eventually, it gets so much that to add just a single new feature might actually take more time and effort than if you were to just start over. That's such a hard discussion to have with your management or coworkers, to just start over. Is starting over, that sounds like you're starting back at square one. We can't. We have to release this thing, but you can't. You're gonna have, it's just too impossible, and just frustration ensures. So there's this idea of, what if there was a no debt approach? So think of debt as the bugs, the glitches in the program. Think of it as the cleanliness of the code, the readability of the code, a whole bunch of things, which I'll go about in here in just a second. That imagine if you were to try to have an approach where you don't let the code rot in any way, where you keep the code, all of the code, at the highest level of quality possible. It does mean when you first start off with in a program, you're putting a lot of effort, and that it may not always be the best thing. If you're doing a startup and you think it only takes you a few units, if you look at the area under this traditional approach here, that's pretty small. Whereas this no debt approach, the area under here looks like it's probably about maybe say 10 times as much, meaning it'll take you significantly a lot more time and effort in the short run to keep a no debt approach. But as time keeps going by and your project keeps growing and maturing and finding new ways of expanding, at some point, the debt approach will surpass the no debt approach. And then you might need to start to do something. Otherwise, at some point, it does keep growing exponentially, and you got to do something about it. Don't worry about these exact numbers. There's no numbers on anything. So if you want, you could always assume this horizontal line's a little higher or a little lower, depending on exactly how little or how much debt you incur in your project. That there is always things where you can allow a little bit of glitches, those really hard to find ones, but nothing too extreme. And so you could be a little bit lower, but it's the idea. So technical debt, that's when it's easy to make something. It doesn't cost much. You just work on code, you hit the commit button or whatever it may be, and you just keep working and working on it. The bad news is by reusing the code, you don't want to reuse that code. You kind of, in some way, have to be forced to reuse various pieces of code when you use technical debt. Conversely, if I may switch and talk about software capital, which is what this whole talk's about, it is hard to create. Oh, I'll show you plenty of reasons as to why it's hard to create. It's expensive as well, in that there'll be a lot of time and effort spent doing things. Sometimes you might not think it's worth it, but I'll have you be the judge on that. But the good news is the things you get out of it, you'll want to reuse it. You'll prefer using that piece of code you wrote previously versus trying to start over or to use somebody else's implementation. With technical debt, the focus is I need this done, and only that thing done. And whereas the software capital, it's a more general, what are you trying to do, and have a bigger focus. It thus produces more beautiful output, whereas technical debt tends to be ugly and incomplete. Software capital can be complete. That being said, you can get out to market faster in the short term if you use some technical debt, but in the long term, it actually will increase your time to market if you do the technical debt approach. So I mentioned this thing called software capital. What is software capital? That's where you write things to be useful, to be clean, to be complete, reliable, general, document it. Now, regarding document it, as programmers, you might not always like to make things write documentation. It's to be bug-free, efficient, and reusable. It's quite a number of items on that list. But if you try to make your code do exactly that, you can certainly imagine why it's going to take a lot of time and effort. But if you did all of that, well, great. That sounds fantastic. We as programmers, it feels like you might want to actually do that. But that's when you find out more details, you might be a little bit hesitant. So this term we have a question?
Yep. So
yes.
On the last slide, you mentioned these points, right? So if, as you said, these are a lot of points. So if all of them are not possible for us to, maintain, which ones do you think would be the most important that would, reduce our debt over time the most?
Good question. It has to be useful. If something's not useful, it doesn't help anybody.
Yeah.
Whereas bug-free, as much as we try, you'd be amazed how easy it is sometimes to have some sort of a glitch, given some overflow. If you're familiar with like a type that has a range of numbers, and if you give it a
buffer
really
overflow?
high, sorry, what was that?
Buffer overflow?
I was just thinking like an integer overflow or something along those lines, but I wasn't myself thinking buffer overflow. So I feel like definitely useful is probably the most important, but then let's see, then, well, I would probably put documented a little bit lower myself. Reusable, I think, is pretty important. I personally, as a user of software, I like it when software is efficient. That I don't know for you if but I assume a lot of programmers are like myself, where when you start up a program and the program shows you a busy wait cursor of some sort, and you're just thinking, I haven't even done anything yet, or I just hit one button and it's waiting or doing something. I keep thinking, what is all of this? Doesn't my computer have a processor in the gigahertz range with RAM in the gigabytes of RAM, 16 gigabytes? Like, I remember back when for anybody who remembers having a processor in the hundreds of megahertz range with 32 megabytes of RAM, or whatever your grandparents will tell you for stories, is, they were able to do an awful lot of things, and it worked wonderfully. Why does things not have to be efficient now? So this one's perhaps more of a personal thing, that as your programs start to scale, efficient is important, but you can get away with a lot of inefficiencies though. So useful, I feel like reliable, that if it's not reliable, probably would be number 2. Probably then general, clean, complete, then efficient, bug-free, reusable, documented, something along those orders.
Gotcha. Thank you.
Okay. Oh, you're welcome. And of course, holler if anybody else has any questions. That term software capital was coined in 1996. And there's a link if you're ever about it. Here's its definition: the cumulative technology that can be redeployed to new situations. And it's the opposite of technical debt, where it actually will pay you dividends instead of costing interest to have software capital. And that you need to do something instead of having to figure it out. You already have it. You could sell that part. You can use it to make things to market way faster than your competitors. And then you'll see that once you have these blocks and they just keep building, you can have, sky's probably the limit for however many. Maybe only these bottom 4 rows are, you keep those up to date as best as possible, and that you might allow a few problems in some of these areas, but it still makes a legitimate product. By the way, with some of the programming languages of today, they talk about programs that the lifetime of that code base to live longer than us as people. Now, I haven't seen a code base yet that existed for that long, but I actually am starting to believe it with just my current code base is now up to 20 years. Sure, it's changed a lot over this last 20 years, but I actually can start to see code bases and software outlive the devices it was originally developed for, and even outlive many people. So you might be saying, all right, I see you have all those bullet points, and I see like you talk about it being great, but just how exactly are we going to build software capital? And we got whopping 7 principles. The first one is code reviews. And so what this is about is you might come up with a name, whether it's a name of a variable, a name of function, name of a file, you name it, and it might make perfect sense to you. But others, if you ever were in one of your CSE courses to just get a chance to look at one of your fellow coworkers' assignments after they turned it in, or however makes the right sense, you might find it a little bit harder to read and think their variable names could use some work. Well, surprisingly, your variable names could use some work too for somebody other than yourself. And so it's the idea of, you might see it as the perfect name, but if you were to get an outside opinion, it might help with that. Likewise, if you have some sort of interface or flow of your program that you think makes the most sense, it might not really make the most sense. It might need work. Now, do you need many of these code reviews? Surprisingly, just a single code review will give you so much feedback that it might just be all of the feedback that you really need. Just one is perhaps all it takes. And what's great though about a code review is it can help you find bugs. Somebody who were to take a look at your code and actually read it and see if they can follow along, they might say, hey, I know that this compiles, or at least they don't believe it compiles, but I don't see any reason you need to loop over all of the items. You know, maybe it's possible just to go through half of the items because the other half are fine. They might spot bugs, see, hey, I don't know if you took this into account, but, you know, what if, you know, do you have your if condition incorrect here, and that maybe it's not even executing this little chunk right here? You might not have been aware of that. And surprisingly, it's actually very simple to just see that little comment and just immediately take a look at it, see, oh, yep, they are right, or sometimes they're wrong, and then make that change right away, and such that you don't have months that go by, a quality assurance team who finds the bug somehow and then alerts the team, then the whole team's looking into the cause of the bug. It's just way easier, way simpler, and every bit better to just find these bugs as quick as possible. And this is a way of doing that. Furthermore, how code reviews help is they can help you standardize on various things as well as socialize things. For instance, I don't know which languages you exact know, but you might have a coworker who will introduce something called a coroutine, or the yield keyword if you're familiar with a language that uses that, and go, wait, what is that? And start learning new things. In addition, it's great when the code is in such a way that you could just go to a file you have never seen before and as quick as possible start following along, that whether it's a syntax related thing, that the spacing, the curly braces, whatever it may be, are aligned to how you're accustomed to seeing it, or whether it's something deeper that they don't use the go-to keyword. They, in some way, they standardize the code, can make it much easier to read along and follow. Code reviews also help around with accountability. Sometimes you do need to write some sort of documentation, whether that's a comment in the code or whether that's something else. If a coworker, you know, sees a problem, they'll ask about it. There's these things called unit tests, which I'll talk about that in a bit. And they could ask, hey, is there enough of these unit tests? And two of which you probably will respond. And then most likely actually make sure you meet the criteria of whatever it is on your team to make sure you have enough unit tests. They'll ask, is this really following the standard we agreed to? Maybe there's a separation of actual logic code from sort of like the view code, and that maybe you might be trying to show a dialogue in some logic code, and they think you need to find a way to do this. In addition, now that another person is familiar with your code, they too are responsible for it. They can help out if you're absent, they understand it, and so forth. But there are some tips. The first one is choose anybody on the team. I know you might have your personal friend who you just love working with that person, but it does make sense to spread it around some, get some other coworkers to take a look at your code. Maybe they have some good insights that you can learn. I'm not saying it'll be perfect, because if there's somebody you really love working with, there possibly is the exact opposite, somebody who you might not enjoy the most, but it nonetheless is a great idea to try to get various mix of people to review your code. And like I said, one single reviewer is usually just good enough. And it works extremely well with those people who love to learn. That if you ever see something new, or if you use something new in your code, and then all of a sudden it works great, where somebody goes, well, I didn't even know you could do this, or what does this override keyword do? And it's just fun to try to explain it at times and to help them. Hopefully these code reviews are now, since this is the year 2020, almost 2021, done with on GitHub or somewhere where they're easily done. But if you don't have access to such a tool, you can still make code reviews work, even with something as simple as email. But one big thing to consider is, if, say, you discover a problem in somebody's code, or you just kind of want to throw around a possible other suggestion, keep in mind everybody that's programming, unless something changes in this regard, is a human. And they have feelings. So you could think about just how best to approach things. And one good way of approaching it is to be polite, be clear. Clear is kind, but nonetheless, ask, did you consider? It makes it so somebody just feels a little bit better and goes, I feel like you weren't nagging, you weren't being just overly critical. You actually were trying to help out. And that does go a long way. Okay, with that in mind, any questions thus far? Move on to the principle number 2. And I was bringing this one up, named standards. It's great when you can reduce your variance across your code base and keep it all in some sort of similarity. And by doing that, it actually will improve your productivity. It even shows professionalism, that if code doesn't follow some standards, it actually can look a little unprofessional. It also improves the ability to find things, that if you know that we use in our product these terms, there will be a time where you're like, okay, I remember we called it a view model, that at least narrows it down some. But if somebody starts just using initial like VM, it might not be so easy to spot that particular file. Likewise, this can actually help with various tooling. Now, with regards to these standards, all kinds of things can be in them. There could be various formatting standards. Do you use spaces or tabs? It could have various idioms. Do you call it a quiz or a question set? Maybe there's a whole bunch more type of naming things. There could specify what is required. Maybe you need to do documentation. Maybe you start specifying the level of code coverage, so forth. It even talks about the organization. And in this case, I'm thinking the organization of your files. That do you just put all the files in one giant folder in one project, or do you sort of have like folders and a hierarchy of some sort? And more or less, it just is about what are the best practices. Now, with standards, tooling is a must. And what that's about, I might disagree myself just a little, but there is fancy key shortcuts to use to just automatically fix your code to follow various syntax related things. Clang format is an example, such that it makes it so anybody reviewing the code never has to be like, hey, I think on the team we put a space before the closing parentheses or something like that. Well, there's an automated tool that has the rules of the team, and that's applied every time you save, every time you run this thing, whatever it may be. And it was ran, so it's one less thing to focus on during code review. The code review could be more focused on the code, like what it does and how it performs, than is it meeting some spacing, new line requirement, something along those lines. then there are various subjective things that might occur. If something is very clear, like this is how we should do things, objective beats out subjective. Concentrate on reusing it. You wrote something, but really, who are you envisioning would ever want to use or reuse this thing? And like I was saying earlier, don't waste too much time or any time on some small things, such as, well, you could imagine a few, but there are some people who talk about, is it okay to do the double equals? It's a C++ thing, but like compared to a constant after the variable, or should you make it something like a true double equals a variable or something like that? You can focus on that if that's important, but for very small things, it doesn't matter the most. Just let them go. Then that brings us up to principle number 3, and this is a big one: unit testing. The idea of unit testing is you can kill bugs before they cause problems. Unit testing, I could do, and many people could do entire talks all about this, but the idea is, imagine you take a very small unit, we'll say a function in this case, and this could even be a public method of a class, and that you were to write tests specifically with various inputs to that public function or just global function, and expected outcomes, whether it's a return, whether it's an exception being thrown, what should it actually do, and then have a whole lot of tests on it. And you specify what it should do and what it shouldn't do sometimes. More or less, you focus on what it does. It helps future-proofing you, just because if you were to modify that function, it has to still continue to do what you expect it to do. Otherwise, it alerts you to that. Maybe the test was written wrong. It gives the impression of dependability. And to that, I have a tool that we use, and I was thinking if I could just take a minute and show it, that what I have up here, we use something called Team City. It's not important, but what is important is we have this test count, and we were at like right around 17,000 tests. This drop doesn't mean we lost tests. It just means this project had some tests moved to a different repo or a different, build. But having however many number of tests really does help out with the impression of dependability. Why? It makes it so if you were to update some framework or some package, or even try out a new compiler or update your existing compiler to a newer version of the compiler, you can have that conversation with your quality assurance people where they go, well, did anything break? And you could say, though I did do a couple of tests myself, you probably were going to anywho, I can tell you we have some number, say it's 17,000 or however many it is, and that they all pass. In addition, if I may, on here, this is just another tab showing the thing. I was just going to show that there's this concept of code coverage. And let me show you some little metrics of various projects. You have numbers, say it's 42% of your code is somehow tested with some sort of a test of some sort. It doesn't necessarily mean everything's perfect. You don't have bugs. Oh no. Sadly, on our project, we do have issues and we have glitches, bugs, whatever you want to call them. But the hope being is that this number is constantly increasing, that it may never hit 100%. I'm actually pretty happy to see some 90% in there. And, maybe 16% is pretty low, but maybe they'll say 17 in a week or a month or so from now. And so unit tests do give safe refactoring. Of course, I'll admit it can slow down some refactoring because in addition to just trying to make the change, you now might even have to do some refactoring in your tests as well, but it can help. So regarding this unit test, you might have, as part of that accountability with that code reviewing, a lot of people give excuses for why this new piece of code does not have unit tests. One reason they might say is this code's part of a dialogue. What do you want me to do? Do you want me to put a dialogue in the test code, or any sort of graphical user interface is what GUI is, type of code? It sometimes can be difficult to test, and automatically some people might say, I just don't want to, and you'll have to have that conversation. It can be done. You do need to have that conversation. Another thing is, this depends on something. It may depend on a codec being installed on the machine. It might depend on a file being in a certain location, being able to communicate with this network server, whatever it may be. There is approaches, of which I do hope you take a look at these approaches, but there are ways with dependency injection to make it so you are talking via some sort of interface that, as far as you know, does network trafficking. It's just in some sort of a test framework, it turns out there might be some sort of a substitution going on where you're really talking to a mock of some sort, something that'll provide you what you want or not provide you what you want to see how you handle. And there's various ways of doing that. Another big excuse you may get from people is, I already know this code is correct. I don't need to write a test. Well, maybe, but it can still be helpful for the future. What if somebody makes your code not correct? By having a test makes it so they'll stand out. But no matter what, you'll probably always get the excuse of, in some sort of fashion of, I need to ship this thing, or I just don't want to, or, you can just imagine all kinds of excuses. And so maybe there is a requirement, you'll have some sort of a standard on your team of, you need to write unit tests for code, and to specify how far. Maybe you'll allow exceptions for GUI code or some of these exceptions. I'm hoping the least amount of exceptions, the better. And so with unit testing, you can have continuous integration. I was briefly showing back here is a continuous integration where every single branch you have, it'll build the entire product, and it'll let you know if any tests are failing. It'll let you know your code coverage, so forth, some sort of a try server along those lines. All right, going to principle number 4. And this one's kind of interesting, contracts. Well, what exactly are these contracts? To use the example, what is a car? Like, what would you tell somebody if they ask you what is a car? Is a truck a car? Well, I mean, I called it a truck. If I may, as a quick personal example, I have a 2-year-old. She sees a picture of a fire truck and she doesn't know any better, so she says car. Does a car all have to have 4 wheels? So it starts to become one of those things of whatever it is you're trying to make, though you may personally have an idea of what this is supposed to do, how this is supposed to work, so forth, that might not be what somebody else is envisioning. And so if you can sort of come up with a precise, complete specification of what you're supposed to see, what you're supposed to experience, and how it's supposed to behave, that can really help. Leave out unless it's important, the implementation details. You might say something's supposed to save a file. That makes sense. If you were to start specifying it must be a JSON file versus an XML file, that's more of the how, more of the what exactly, not the how or what it should do. So it's something to just keep in mind. If it's very important that it's a JSON format, then you got to specify it if that's very important. And then some of you might be thinking that the code for the program itself is documentation of how it works. I can tell you, personally speaking, no, that it does not work all that well. There's quite a number of times our quality assurance team will say, hey, I'm experiencing this behavior. I can't actually tell if it is how it's supposed to work or not. Is this a glitch? Is this a bug? And then I can even tell you, even after reading what they're seeing and seeing it myself, I go, I actually don't know if this is a bug or not. And then just looking in the code, well, of course, the code makes it do what makes everything happen, but is what they're seeing a glitch? It's the program gets so complex that what you see happening, it really, I just can't say. And so there becomes times for contracts. And what's great is these contracts make it so it's very clear ways of defining whether something is doing what it should do or not. It allows, it saves time. You can, I don't know, one of the big things is it provides guidelines for what you should write unit tests for. If something must perform in this particular fashion, well, good, there's a test that shows in that fashion it does what it should do. Another test that in some slight variation, it does what it's supposed to do, and so forth. And then starting to see what the various contracts are makes bad interfaces stand out. Now, of course, you know, I don't know if you want to read something so legalese. It might just be just spelled out just in general form, nothing too legally contractual. I'm just thinking like just specify what it should do. If interested, companies, some of them have their own contract specifications. You could follow their particular standard. But moving on. By the way, everybody's still doing A-OK. Principle number 5, and there's just a couple more after this, good interfaces. I'm sure we've all wrote a program or two where it just does one thing. It doesn't ask for any user input. It just does what it does, and then that's it. And wouldn't it be nice if there was just an easy button? But you'd find out that's so small, and that almost anything you write, if you were to write a tic-tac-toe program as an example, you need some user input. It's not just so easy. You might want to make it a little bit more complicated because you just feel like, hey, it just is a little bit, before you realize it, it's just a little bit more than you realize. It's great for when you do separate your logic of your program from the drawing or the interaction. For many reasons, you should look up on that. And so I think you should try to strive for having as best of an interface as you can. And this isn't necessarily talking about the user interface. This is more specifically trying to talk about the underlying code of how things communicate type of interfaces to each other. And it is difficult. It sometimes can be an art form. Sometimes there is no right answer. That for those of you who are familiar with a function callback, they can look complicated, but sometimes that's the most clearest, best way of I don't know, writing something in your interface to have two things communicate. And you do want to be general in all the right ways. We have this term called YAGNI. You ain't gonna need it. So it makes sense to be strong and general and robust where it's necessary. But there are times where you're just writing good code and it might not be necessary. That being said, you know, it's okay if you be a little general in some ways, just don't overdo it. It's great to have nice simple contracts where this thing doesn't have to meet so many arbitrary complicated things. It's spread apart some, and they're nice simple manageable pieces, and it's built on some patterns that you've already seen and you're getting familiar with. And yes, naming is important. Seek a code review if you could utilize it for better naming. All right, everybody doing A-okay? All right. Innovation. Believe it or not, code will start to rot. That you could have wrote a program back in the days of Windows 95. It probably, if you were to see that code, even if it were well written back in 1995, the language has probably changed that, or probably might not even exist anymore, but probably has been changed, and you should try to follow the new techniques. And new stuff is great, but it most always does add some new complexity. And you really do need to try to keep innovating with your code and with your program. Otherwise, you'll slowly occur this sort of debt in your programs. There'll be new approaches, and if you're not familiar with them, you will start to fall behind. Okay, well, how do we go about that? Well, for instance, you can go to conferences, you can read books and code reviews. Your fellow coworkers might actually know something that you don't and be able to help you with that. Another way of innovating is just modernizing your code base. You should make this a priority. It can, by modernizing your code base, helps, if you're using the latest compilers, they'll often help you, giving you new diagnostics that your older compiler could not. It probably has efficiencies that you weren't aware of, as well as it gets you into, probably gets you into new environments that you were not aware of. Anytime you can automate things, definitely helps too. That if somebody's doing something manually, if it's possible, they could click the equivalent of an easy button. That would help out quite a lot in that case. And that gets us to the final principle, infrastructure. Infrastructure is a broad term to mean quite a number of things. For instance, version control. Version control is like a Subversion or Git or one of many other type of things. There are, sadly, I've seen a couple myself, companies that don't use any sort of version control. They just have this folder of files, and they just update a file or two in there. Just however, they just copy and paste from somewhere into this folder, and hopefully it never gets broken. I think in this day and age, since there's all these tools that are free with version control, you should definitely do that. That being said, I also think with continuous integration, like what I was showing on that Team City thing, there are free ones, both as in no cost, but also as in the license is such that you can see their code and modify. Having various build systems, all of these type of things from just everything is part of infrastructure. Keeping up the standards. If you're familiar with C++, there's various, you can almost call them dialects. There's C++ 11, C++ 17, just a standard that you'll try to update to the newest standard if that's something you're interested in. And the thing about this, any of these infrastructure items are not easy. In fact, they're difficult, quite difficult. I would not give them to the intern of any sort, because in programming, there will be times you'll get stuck. And then there might not be a Stack Overflow article or an easy way of resolving that problem. Sometimes you have to just figure it out, try it around a little, and you, as you get more experience, will start to know, like, or sort of have like a knack for trying things and trying something new. And you can oftentimes get around that problem that an intern might not. So some of the highest level of expertise is required to help out with the infrastructure. And of course, if you don't do it right, it just means now you left something for somebody else, and that's pretty much technical debt. So with that, I just got a couple more things, and then I'll take some questions. So that, if you can do all 7 of those principles, you can start building some software capital. And software capital, I consider it the real value of your organization, your ability to have something and have something that is worthy and valuable and something others seek out. And by building software capital, you can build things sustainably and even have a competitive advantage where you'll be able to make your program do something, and in fact, quite a number of somethings that your competitor will start to slow down with just a few somethings. That's software capital. So, do we have any questions? I'll open this up a little. All right. So if you have any questions you just want to ask me afterwards, go for it. And
we have a couple of questions in the chat, I think.
That probably makes sense. I wasn't looking at the chat window. All right, give me a second here as I switch to chat. Hope I didn't miss too many, but you're right, I do see a couple. Okay, so the question, and from 619, let me see if I don't know if I answered it. How do we determine the critical point for quality of code? And I don't know if this had to do back when I had that graph, like
about the graph.
Oh yeah, and there's always that question of, you know, at what point am I doing good enough? Am I getting diminishing returns? For me, I feel like that depends on just you'll sort of internally you'll sort of vocalize that if you have various retrospectives amongst your team, that if people feel like they're in meetings all the time and you were to just ask them to be honest and tell me how things are going every once in a while, they probably will tell you, I feel like I'm in so many meetings. And then you'll take a look and you might go, uh-oh, these are actually very important meetings. I can't just reduce any more meetings. Maybe there's the team's too big, or something to do with the quality of the code, something along those lines. So the way I would find it is just asking people, and maybe everything's going great, and then you may not be at the most optimal point, but if you're happy and people seem pretty happy with how things are going, that would work. But ultimately, the way I would find it and determine it is more or less asking. It doesn't have to do with any charts or graphs or revenue statements. It's just talking to people and getting honest feedback. Of course, you want to make sure it's honest, because if it's not honest, it doesn't really help.
A follow-up question on that would be like, what would be a sweet spot for the code coverage? As you said, that 100% is not possible a lot of the time. So, and 16% is obviously not as good. So what would be like a sweet spot, or is there no such thing when it comes to code coverage?
That's a really good question. Sadly, there is no real such thing. I think management would not mind at all if it said 2%. But 2%, if you want to think about it, that kind of just means 1 out of every 50 classes, functions, whatever you want to say, has some code that just runs through it. So there may not be that, but it would definitely depend on what industry you're in. That if you had something that's very critical, and I'm thinking something along the lines of an airplane or medical technology, the more you could do to make it so it could not possibly harm a person, the better. Because not just because that could expose you to lawsuits or something along those lines, but just from some sort of ethical standpoint, if you believe in that. And then at the same token, sadly, it sometimes does make sense, though you want to strive for as much as possible. When the rubber meets the road, you do need to, if you're a software company, you do need to release every occasionally. And so, though it would be nice to get that 100%, you sort of do as much as you can do. You'll feel like as you're programming, things feel pretty good. I feel like anything 50% should be good. Now, 50% does not mean you actually make sure every line is good or anything like that. It just means you called this function, and maybe you only have one return statement at the end of the function. All those lines of code got hit, maybe assuming they weren't inside of some if branch or whatever. It just, so therefore it makes it so your numbers at least look nice. And there's ways you can lie with statistics and all of those type of things. But I feel like if you're not doing somewhere around 50%, you could be doing better. Now, that's my opinion. I'm sure somebody else doesn't have a number, and somebody else, there might be a change, which for one reason or another, it's very difficult to get 50% for why, who knows, but in that particular change they're doing. But yeah, I would say that.
Gotcha. Makes sense. Thank you.
All right. I see another question here. Oh, wait. Two questions, actually. So this person asked, what's the hardest part of maintaining software like Camtasia that uses a memory unsafe language? In terms of memory unsafe, that's actually becoming easier and easier. So I'm not sure exactly what's taught in CSE 232 at the moment, but there's these things called shared pointers or standard shared pointers. And the idea is no longer do you have to worry about when you're done with something, you free it. You like if you allocate it some memory to make sure, or like if you open a file to make sure you close it, that when nobody's touching something anymore, that class's destructor gets called, and the destructor will close a file, close a stream, or free up some memory. You might sometimes want to do something memory unsafe. But so that's surprisingly not at all a big problem, as I've been finding out. That I'm in some like little C, the programming language, C user groups. And one of the biggest misconception they feel is that because they use raw pointers, meaning just you have an address to a location in memory or something like that, that your program therefore is going to be incredibly buggy or incredibly crashing and so forth. And I don't know if you guys know, but that program Git, as just an example, the GIT program, that's programmed in C. So you can, and surprisingly, a lot of things that you don't realize are programmed in C. But nonetheless, what's the hardest part of maintaining it? In simple terms, I feel like the user interface has been thus far one of the hardest parts, and that we're constantly have been changing. We used to use some called Microsoft Foundation classes called MFC. Now we're using some called WPF, which stands for Windows Presentation Framework. And there's always talk about some called XAML, and it changes quite fast, as well as in addition to just whatever we use some called Qt, spelled QT as well. But in addition to those aren't too bad. I mean, you're just adding buttons and drop downs or combo boxes or whatever. It's there's always times where you need to make custom controls, or you have to just keep changing things. And it turns out maybe you didn't make your things adaptable to change that easily or something along those lines. But yeah, I would say definitely for me, the hardest part ends up being the UI the user interface of the program and just doing what you want it to do. Let me know if I answered that one good enough. And concurrently, so this question here is, does code debt, oh, you're welcome. Does code debt depend on the language framework used or more on the project itself? I think code debt is independent of the language used. So for C++, you can write tests, you can get code reviews, you can, I'm pretty sure any programming language, you're gonna have to come up with names of whether it may be variables or functions. You'll probably, I think every programming language I can think of has files, and these files, hopefully that's correct, have a name. So in terms of technical debt of any sort, which can mean so many things, it really is independent of the language and independent of the framework. That being said, using a language that helps you be as efficient as if you want to be, like if you have a critical path where you might have to wait for it to render out a video. If you are using a language for that portion, at least, you can be multiple languages in a program or have multiple processes, each being different languages. But anywho, if that part, you have the ability to streamline things, that can be helpful. Whereas if you were using a higher level language, there's a chance where no matter how well you write that code in that language, it'll always, just have a certain burden of slowness or of memory usage that can just be undesirable. And I already said it's a burden, so I think of it as a burden sometimes. If you ever choose something too high of a level language, and then it's great to get started. Before, if you're curious, before Facebook, there was this thing called MySpace, and they used a language called Cold Fusion, and then they sort of reached the limits of what that was capable of. And obviously watch a documentary on this to see for yourself. But more or less, there's some really amazing quotes from Facebook in this case, saying it's not that they did it any better or anything than MySpace. They felt there's more of MySpace blew it. That MySpace, they had an opportunity, they had the market share, they had a lot of things. It just, they just could not compete, and they lost it, type of a thing. So hopefully that helps with that question. And if so, this next question is, what is your favorite, most cherished memory of working in the field or from your life? And and there's a form. I wonder if this is, I think that's for everybody who came to this talk. So there's a lot of things. Obviously the people that I've got to meet are some of my most cherished memories. There's this buddy who has since left the company that I've been keep telling myself I need to contact that person and get a hold of them because, he was a great friend. There's people who still to this day I work with, and I so enjoy working. But I don't know if you want like a particular favorite example, but there have been some coworkers who married each other. I didn't. Wife's out there, but and she's never worked at TechSmith. But yeah, there's relationships that's formed. There's a lot of really good people that I enjoyed working with, throughout my time. And there's some really amazing things about TechSmith, if I may talk about that company for a second, that since graduating, I started working at TechSmith, and I told some of you I graduated in 2006. Now it's quite a number of years still working there. and that's a little bit unheard of in the software industry, where the average turnover might, I don't know, but I'm going to just say 6 years or 4 years. So for those of you who took statistics, I bet you that's a couple of standard deviations more, if not quite a few standard deviations. So I enjoy that. Being in the programming side, just if you're curious, I don't tend to get super excited over in a release coming up, just because by the time the release actually happens, I'm a couple of months into a maintenance that'll be coming out, or whatever that next step is. So in a sad way of seeing things, is what you might have actually installed on your machine. I do as best as possible, try to make it be the best quality possible. But, you know, what I'm looking at every time I do a build is a couple of months of fixes and of improvements, and that, if at all possible, I want you to use that. But it's going to be a perpetual thing. I'm always going to be, you know, working on the latest, greatest version of the product. That I would rather everybody could use that one than the one you'll actually ever be using. And I don't want you to either to have to uninstall and reinstall or update daily. Anywho, so let's see. I have a picture of my daughter, and having a child is probably my favorite memory. And these last 2 years have been the best couple of years of my life, just because of my daughter's a couple of years of age, and everything has been so wonderful there. But that has nothing, sadly, to do with programming or anything of my field of programming. But those are my best memories, is that.
Wow, that's beautiful, AJ. Thank you so much for like sharing that with us and sharing this talk with us. We definitely learned a lot. I definitely learned a lot, if not anyone else. For the attendees, there is the form for attendance in the chat. Please go ahead and fill that out, so we can keep track of who attended, and if you have any questions, please let us know. AJ, will you be sharing the? Yeah, there is a quick question for.
Oh, and I can give it a little bit bigger answer. For my case, because we make a video editor, video editing, you kind of want it to be fast, because it's got to display an image that could even be 4K nowadays, or bigger, on the screen, say 30 times a second, and it could be all kinds of things happening on it, or like some of those AAA games. If you play video games, you want them to be fast. Yeah, you might still notice loading times, and so we do C++, and C++ in terms of performance. I mean, check it out for yourself. It gets pretty close to the C language, and it's surprisingly, if you think assembly and stuff, just handcrafting it better. There's talks about how there's many assembly programmers who really believe that writing assembly would get them the best possible performance, and then they tried around with some C and C++, and then found that the compiler actually produced better assembly than they were handwriting. So C++, partially because it also came about. Now, we do use C#, just because you might have heard me mention WPF. We use that a lot for the UI type of code, the buttons, just because to have a dialogue with a couple of combo boxes in it, it doesn't necessarily need to be C++. I personally would love to if it could ever be possible, just make it so we don't have multiple languages throughout the program, for many reasons. One of the big ones that makes it so anybody new to the program would have to learn more than one language, more than one framework, and for various to know both C++ and C#. That if you got to know C++, if that were sufficient and we wrote it well, you'd be able to be onboarded onto the program a little bit faster. And then, so that's a big thing, is onboarding of new hires, or just getting people so they don't have to learn many things. It would make it so you don't have to do any interoperability, that if for whatever reason you need to pass data this way or that way from the C++ to the C# or backwards. Well, if it was all C++, you just are just passing a pointer or passing a reference or a shared pointer, whatever it may be. That's super easy. But if you have to do something called marshalling, of take this thing and copy it, but into like a similar but different type, it just adds noise and just adds some waste, but it has its reasons.
Gotcha. Perfect, AJ. So yeah, as I was saying, everyone, please fill out the attendance so we know who attended, and if you have any questions, please let us know. AJ, would you be sharing the slides with us so that I can share them with the people who attended?
Of course. And likewise, if anybody just for whatever reason wants to stick around after all this, I'd be more than happy to stick around for as long as anybody needs or desires.
Okay, but yeah, as of right now, the talk is over. Please let AJ know if you have any questions for him.